In this video, we will review the angle-arc relationships that we have learned so far. Specifically, these are the ones. First, we learned that when an angle is having its vertex at the center, then the angle and the intercepted arc are equal. So I'm talking about this arc right here that I just drew in red. The angle equals the arc. On the other hand, when you have an angle whose vertex is on the circle, in fact, let me label all these. So when the vertex was at the center, the angle and the arc were equal. When the vertex is on the circle, this is called inscribed, then the angle is half the arc. Or you could say that the arc is double the angle. Now, if the angle is in the circle, but not at the center, then this is the formula that we use. We have these two arcs, the x and the y, and the angle is the average of these two, arc plus arc divided by 2. And I encourage you to look at this as some kind of a bow tie or an hourglass to help you identify the two arcs and the angle. Okay, now if the angle is outside of the circle, like this, then the formula is almost the same, but we have to do arc minus arc divided by 2. And those are the two arcs. And you really want to do the big arc minus the small arc so that you will not get a negative number. Okay, take a look at number 10. Here's the target down here from D to Z. So I'm going to call that X. Alright, eventually I'm going to have to work my way around to that. But let's start with what we know. The only number that we're actually given is this 58. So that's a great place to start. Let me trace it. Here is 58, that goes like this. Well, that is another angle that is on the circle, isn't it? And as you've seen several times now, when the angle is on the circle, the angle is half the arc. The arc is double the angle. In this case, I'll think of it that second way. The arc is double the angle. So if the angle is 58, I'm going to double it and get 116. So this is 116. Okay, is that enough information for me to find this over here? I think it is if we use the magic of diameters. Notice that this blue line I'm drawing is a diameter. That means that we have a semicircle over here. Okay, this is a semicircle. It has to add up to 180. So I should be able to find x by subtracting the other part from 180. So if I start with 180 and I subtract 116, that should give me the missing x. So that's exactly what I'm going to do. 180 minus 116. That is 64. So x was 64 degrees. Now for problem number 11, ultimately I need to find the length of, the measure of arc TG so I can solve for x. However, the only number that I'm given is this 55, so I really need to start with that. Now this is actually my second attempt at this problem. I had to delete my first attempt because I thought that this 55 degrees was supposed to be this angle right here, the angle that is clearly closest to. But turns out, no. This 55 degrees is supposed to be this angle right here. Okay? So, that suddenly makes the problem solvable. So this purple angle that I'm tracing right now, this is the 55 degrees. So do you see how this is on the circle, right? The vertex is on the circle. That means we're going to use this formula, which says that the angle is half the arc. Or you could say the arc is double the angle. All right, since we have the angle, we can double it and find the arc. So we can find this arc right here. So that's going to be 110, of course. So this is 110. Now, notice that we have a diameter right here. So that means this side of the line is a semicircle. So this all has to add up to 180. So in other words, 110 plus this 14x has to equal 180. So I might subtract 110 from both sides. So that's going to give me 14x is equal to 70. And then if I divide both sides by 14, then x is going to equal 5. Number 12. The trick to number 12 is understanding a couple of things. First of all, we have an angle right here that is on the circle. Boom. This angle is on the circle. That means we should be able to use this formula where the angle is half the arc. Now, how does that help us? Well, because look, can you see that this is the arc right here? But that is a semicircle. All right, do you see the diameter that cuts across right here? So what we have is a semicircle. So half of 180 is 90. So that makes this a 90-degree angle right there. Okay, so that's the first trick. Now I'm going to erase that so you can focus on the next thing. Okay, maybe I'm going to change that color a little bit. So, all right, we figured out that this is going to be 90 degrees because of the semicircle. Now, meanwhile, we have another one of those angles that are on the circle, inscribed angles, right here. This angle is also on the circle. All right, right here at L is on the circle. And do you see that this is the arc that goes with it? The intercepted arc, if you will. So again, remember, the angle is half the arc. So if the arc is 66, that means that the angle must be 33. So we have a number or an expression for all three angles inside this right triangle. Okay, so I'm looking at this red right triangle. We have 33 degrees, we have 90 degrees, and we have 4x plus 1. All of those need to add up to 180. So if I do 4x plus 1 plus 90 plus 33, that has to equal 180. $124. So you can see that I have these three like terms right here. That's 124. So now I have 4x plus 124 is equal to 180. If I subtract 124 from both sides, that's 56. All right, so that is going to be 14. So x is 14. All right, number 13 seems to suddenly get much easier than all the other problems, so it's a little bit weird. This is just a straightforward application of that the rule about having an angle that's on the circle. All right, see how this is on the circle. That means the angle is half the arc, or we could say that the arc is double the angle. So that means that this arc is 80, right? 80 degrees. Okay, let's slide over to number 14. Okay, this is a whole new formula that we haven't seen yet on this worksheet anyway. We're dealing with this situation. When we have the angle that is outside of the circle, then the angle equals arc minus arc divided by 2. So I feel like we should just plain write that down in words right now. Okay, so the angle is equal to arc minus arc divided by 2. Okay, luckily the angle is what we are looking for, so I'm just going to call that x. So I can just put x in for angle. So we really need to have both of the other two arcs. So check this out. Of course I have one arc that goes from here to here like this, but I also need the other arc, the major arc that goes the long way around. They did not give it to me. How am I going to find it? Well, together these two arcs form the entire circle. So can you see that I should be able to get the purple arc by subtracting from 360? If I take the whole circle and I take away the red part, that should leave the purple, 245. Okay, so the purple arc is 245 degrees. So arc minus arc, please understand that we are doing the big arc minus the small arc. Otherwise we'll get negative numbers. So we're going to get we're going to do 245 minus the 115. And that's how you do it. $65. So x is 65. 65 degrees. Now number 15 looks a little bit strange with lines shooting everywhere outside of the circle. So there's something I want to walk you through slowly. So say if we have this circle, okay? Now, I think you're pretty comfortable with the idea that if I have an angle whose vertex is on the circle, like this, then, for example, if this arc out here is, let me change colors. If this arc out here is 60, then the angle will be 30. think you're pretty cool with that. Okay, so here are some things that I need you to understand. What if I take this side of the angle and I make it wider? Okay, and just for fun, I'm going to let it stick outside of the circle a little bit. That's not really going to change anything, will it? Okay, so for example, now let's say that this angle is 50. Can you see that this arc out here is now going to be 100? All right, the same rule about an angle that is on the circle still applies. All right, let's crank this out even further. Okay, let's say if I take this to an extreme and I make this angle so wide that one side of the angle is now a tangent line, like this. All right, it's a tangent line. If I drew the other side, it would go like this. It would be a tangent. Now, so let's say that this angle is now, let's call it 110. Now the arc, so just to be really clear, this arc now goes from here all the way in. All right, it goes all the way into the point of tangency. But guess what? The same rule still applies. So if this is 110, the arc has to be double that. So this would be 220. Okay? Even if I drew in the other side of the angle like this. Alright, so now I have lines shooting everywhere, but that's okay. This still counts as an angle that's on the circle, and so the angle is half of the arc is still double the angle, even if I have lines shooting everywhere. So that's what is happening on this problem right here. So focus your eyes, for example, on this angle right here. All right, this is one of those angles like I just showed you. All right, the vertex is right here, point E. That vertex is on the circle. So that rule about the angle being half the arc still applies. Now the arc I'm talking about is this arc right here that goes all the way around like this. All right, that's the 270. But the angle should be half of that. So half of 270 is 135. All right, just in case you don't believe me. Okay, so that means that this angle right here is 135. All right, half of that arc. Okay, but we are supposed to find this angle over here that I'm drawing now in green. Well, just to make it more clear, I'm going to erase this purple for a second. I'm hoping you can see that this is a linear pair. All right, this tangent line is a straight line. So together these two have to add up to 180. It's a linear pair. So I should be able to go 180 minus 135. And that should give me the missing angle. So that should come out to be 45 degrees. Here comes another problem where the angle is outside the circle. We spoke about this earlier. Remember, when the angle is outside the circle, the relationship is angle is equal to arc minus arc divided by 2. And these are the two arcs in question. So I like to write down that formula in words first. So the angle is equal to arc minus arc divided by 2. And remember that's going to be the big arc minus the small arc. Alright, so what are we dealing with? Hopefully you can see that the angle is right here. See how pointy it is? That's how you know it's an angle. So the angle is this 35 degrees. So the 35 degrees goes first. So I have 35 degrees. Now, I've got the big arc is this. Okay, that's the thing we're looking for, so we can call it x. And then the small arc is this. And that's 59. So we need to do the big arc minus the small arc, so that's going to be x minus 59. So that's the setup. Now the way you solve this is by multiplying by the denominator. We've got to get the x out of here, but to get at it, you want to multiply both sides of the equation by 2. Alright, that way these 2's will cancel each other out. So that's going to give me 2 times 35 is 70. So I will have 70 is equal to x minus 59. And then I'm going to add 59 to both sides. Okay, so that's 129. And that's degrees, because that's an arc. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.